So now in section 2.4, we're going to look at some typical types of problems that where we'll use algebra to solve them. So direct translation problems, and then how to solve problems that involve relations to unknown quantities. That was your two pieces add up to a total, and then consecutive integer problems. So in the last section I started you modeling on these, but now we're actually going to solve them. So let's look at classroom example 1. We're going to do a direct translation reading the English statement and put it into an algebraic expression. And so x is going to stand for the number. 3 times the number. And you see that comma, that means perform that operation 3 times the number. And then what is happening with that 3 times of the number? That is being subtracted from 2. Remember that construct where something is being subtracted from. The second expression goes in front. So 3 times the number being subtracted from 2 equals, well, that's an equal sign, twice the number, and see that comma, that means represent twice the number first, added to 27. Find the number. That means solve for x. So let's go ahead and we'll want to get all the x's on one side of the equal sign. So I'll subtract 2x from both sides. So we bring down the 2. Negative 3 and negative 2 is negative 5x. Bring down the equals. We've got 27. So I'm not going to worry about that negative 5x. The first thing I want to move is this 2. Right now I have a positive 2. I want to move that 2. Think of picking it up and putting it on the other side. We're going to subtract 2, but whatever we do to one side, we have to do to the other. So 2 and negative 2, we're going to be left with negative 5x equals 25. And if you divide both sides by negative 5, a positive divided by a negative is negative. So we think the number is negative 5. So let's check. You always want to check your answers. 3 times the number subtracted from 2 equals twice the number added to 27. If this comes out to be a true statement, that means that negative 5 is a solution to the equation. All right, so we have the 2. Negative 3 times negative 5 is positive 15. 2 times negative 5 is negative 10. Bring down the plus and the 27. 17, does 17 equal 17? Yes, it does. So that means x minus 5, x equals negative 5 is the correct solution for x. So you're going to go and do practice 1. Practice 1. It's been a while since I've shown this, but this is how you know you've got a practice problem. Here's practice 1, and you see the little green box. That means that that's the problem you should do on your own. Stop the video and do that problem on your own. Okay, so let's do classroom example 2, doing a translation. 3 times, and what are we multiplying by 3? What are we finding 3 times? 3 times what? The difference of a number and 5. Difference means subtraction. The number comes first, the 5 comes second. 3 times what? 3 times the difference of a number and 5 is the same as, that means equals, twice the number, and there's your comma meaning stop, so twice the number, and that being decreased by 3. Notice this is not subtracted from 3, this is decreased or subtraction by 3. Find the number, solve for x. So we'll distribute the 3, we'll get 3x minus 15 is going to equal 2x minus 3. And let's get the x's on one side. We'll subtract 2x from both sides. 3x minus 2x is 1x. And then bring down your negative 3. And so we want to get the x by itself, so let's add 15 to both sides. X equals 12. So we think the number is 12. So let's check our work. Let me write the word check. 3 times what? The difference of a number and 5 is the same as twice the number decreased by 3. 12 minus 5 is 7. 2 times 12 is 24 minus 3. Does 21 equal 21? Yes, it does. So we've just checked our answer. So now you can go ahead and try practice 2. In classroom example 3, I want to remind you when you have two categories that add up to a total or add up to a sum, something that's complete, you're going to use one of the variables is x and the other is the total minus x. And these two added together will equal your total. And here's a typical example. An 18-foot wire is cut so that the longer piece is 5 times longer than the shorter piece. They never tell you it's cut into 2 pieces, but you can infer that from the fact that there's a long piece and a short piece. All right, so if we were to kind of draw a picture of that, here's my 18-foot wire. Okay, and here's the short piece. And here's the long piece. So we've got 2 pieces, the short and the long. This plus this is going to equal 18. So how would I model that? An 18-foot wire is cut so that the longer piece, that's this one, is 5 times longer than the shorter piece. So the short piece is x, and the other one is 18 minus x. That's your construct. One is x and the other is total minus x. And what am I told here? The longer piece is, that's this one, 18 minus x. The longer piece is, this is the longer piece, 18 minus x. That is the longer piece. The longer piece is 5 times longer than the short piece. 5 times longer than the short piece. So the first part is to set up x and 18 minus x. Here our long piece is 18 minus x. The long piece is 5 times the short piece. So now we're going to solve for x. So we'll add x to both sides. We'll bring down the 18. Bring down the equals. 5x and 1x is 6x. Divide by 6. So x is 3. So find the length of each piece. You're not just going to circle this and say x is 3 is your answer. X is 3. That's the value for x, but the question was, what's the length of the long piece and what's the length of the short piece? So we have to go back here, and we're going to see the short piece is 3 feet. And the long piece is 18 minus 3, or 15 feet. The long piece is 15 feet long. The short piece is 3 feet long. That's what you want to put a box around. And they do total up to 18 feet. And the longer piece is 5 times the shorter piece. So why don't you go ahead and now you try practice 3 from section 2-4.